Okay, Frank. What questions do you have? Yeah.
20.
20?
Mm-hmm.
Okay. Ooh. Okay. So they gave us this, and they say we have this. There must be a mistake made. Okay. So let's see. I'm going to do the correct version of it. So that's equal to this. Is that okay so far? And then this next step is going to be this. So that gives me root 15 over root 25, which then that gives me this. Okay, so, oh, found the error. Here was where the error took place. They didn't multiply that on bottom. Okay. What else did you see on this worksheet? Did you like to go over?
19.
19? Yeah. Oh, it's another one that has some sort of error in it, huh? Okay. So we got root 50. All right, so let's see what we did. The next step should be this. And then, oops. And then the square root of that should give me this. And let's see. Oh, they flip-flopped them. They had the 2 outside and the 5 inside. So here's where the error took place. What else did you see?
Can you do 9?
Yeah, buddy. That one, right? All right, so I'm going to multiply here. So there's only a 1 outside, so 3 times 1 is 3, and then inside root 5 times root 2 is root 10. Is that okay so far? I'm not done with it yet. I'm just trying to make sure. Plus sign comes along for the ride. 3 times 3 is 9. Root 5 times root 5 is root 25. You feel comfortable with that? I'm not done with it yet, but does that seem okay? Okay. 10 only breaks down to 2 times 5, so there's no perfect squares. But what's the square root of 25? 5. So that's 9 times 5. And then 9 times 5 is 45. There it is. Try to include all the steps. Does that make sense, the thought process? What else would you like to see?
Can you do 12?
12? Sure. Number 12. Is that the root 98? Something there? This? Then we have x to the 5th, y to the 3rd. Is that right? Okay. Tell me, where should I start on this problem? Well, let's think about our perfect squares. That should be far enough. What is the largest perfect square that goes into 98? Does 100 go into 98 evenly? When I say that, if you do it on your calculator, you go 98 divided by 100. 49? Yeah. So how I would start this is start from the bottom and start eliminating ones that you know that aren't going to work. So that'll work. 49 times 2 is 98. Is that okay? So let's just rewrite that like this. And then I'm going to change that to x to the 4th and x. And I'm going to change that to y to the 2nd and y. Okay, why did I change x to the 5th to x to the 4th x. What's x to the 4th?
X squared.
Yeah, it's a perfect square, so if I take the square root, it becomes x squared. And then the square root of y squared is y. Okay, so where's my perfect squares up here? Is 49 a perfect square?
Yeah.
Okay, so what's the square root of 49? 7, so it comes outside. There's no longer a radical sign that goes with it, right? Because it was perfect square. What's the square root of x to the 4th? Squared, it's always half. What's the square root of x or y squared? Y. Now, under the square root, what's still left behind? 2. What else? X. What else? Y. Yeah, that's it. What else would you like to see? Yeah.
I'm just really confused on how to remember how to do all of them because they're all different. Like one's multiplying.
Let's do another one. Let's see.
Okay, can you do?
And I'll come to you. What?
11.
11. Yeah. I'm going to treat this one just like FOIL. Do you know FOIL, okay? So I'm going to go 1 times 1, 1 times negative root 3, 1 root 3, and then minus root 9. Does that seem okay so far? Yeah.
Why would you go 1 to the negative? I thought you had to do inside, and outside. How did I use the 1 goes to the negative 3? I thought I had to stay within the radicals.
So where you at? You're good here, right?
Yeah.
Here?
Yeah.
Is that good there?
Mm-hmm.
Good here?
Mm-hmm. No, I just don't understand. I thought you could only multiply radicals with radicals.
Yeah, right. So only outside to outside and inside to inside. Yeah. So here to here is inside inside. That's why I got a 9.
Right.
But then I have outside to inside, and outside to inside.
Uh-huh. So
this is going to be 1 times negative 3. That gives me that. So technically, I don't really need to have these 1s there.
Mm-hmm.
I just put them there because to show. All right. So what can you tell me about right here?
They cancel.
They cancel. Good. Yeah, the one's positive, one's negative. What can you tell me about this? What's this?
Perfect square.
Perfect square. Square root of 9 is 3. Hey, where'd the square root sign go? Well, I used it to get the 9 because it was a perfect square. Now then.
Wouldn't it be? Wait. Okay.
You had a question? Lumford? Okay. Yeah. Yeah, Kirsty, 10. How much? 10. 10. Root 3. And then 4 minus 2. Root 3. Alright. Alright, so we're just going to distribute. So if I multiply that times that, it means I get 4 root 3. Is that okay so far? So I didn't multiply anything outside to inside. I just multiplied them together. Okay, a minus sign comes along. We multiply this times this. I'm going to get minus 2 root 9. All right. Can I break root 3 down any further? No. So 4 root 3 might be sticking around as is. The minus comes out. Hey, what's the square root of 9? 3. What is 3 times 2? Done. Where did the square root sign go? Well, I took the square root of 9 and got 3. Well, where'd it go? It undid it. It's gone.
Is that your answer?
Uh-huh. And notice it's just a square root 3. It's not a square root of 3 minus 6. I don't have the square root going real long. What else did you see?
Can you do 13?
How much? 13?
13.
Yeah. Root 144. Third. Okay. All right, there's kind of a lot to this problem. because we have a y to the third in the denominator, but we'll deal with this when we get to it. So let me ask you, friends, what's the square root of 144? 12. How do you know that? Well, you go on your calculator, go square root 144, or 144 square root. It depends how your operating system works. So that gives me 12. What's the square root of x to the 6th? X to the 3rd. Everyone feel okay with that so far? Okay. Where'd the square root sign go? Well, I took the square root of 12, or 144 and got 12. It's gone. Where'd the square root go with the x to the 6th? Took the square root, which is half of it. What's the square root of 81? 9. Okay. And then I have to recognize that this is y squared times y. Do you agree with that? What's the square root of y squared? Y. Is there something left inside? Y. So I have that. Okay, so we're like totally, really close to being done with this problem. Okay, does everyone feel comfortable understanding how there is a square root y on bottom? Because it wasn't a perfect square. So what I'm going to do is I'm going to go ahead and multiply top and bottom by square root y and square root y. So on top, I'm going to get 12x to the 3rd square root y. And on bottom, if I multiply these together, I get y squared. So what's the square root of y squared? Just y? And then y times this y is? Y squared. Is that okay so far? Now, and I won't give you this like on the quiz, but there's a little tiny one last gotcha on this problem. Does anyone see it? Talk to me about 12 and 9. What number goes in about 12 and 9? 3. So 3 goes into 12 4 times. 3 goes into 9 3 times. And I get that.
Why did you move the y squared up?
Why did I move it up?
Yeah.
Because I had y to the third originally, so I broke that to y squared and y.
Okay.
Square root of y squared is just y, so that's why the so right here, I don't want to have this. So I need to multiply that, the y on both top and bottom, because root y over root y is 1, so I'm not changing the size of the fraction.
Yeah.
So I just don't want it downstairs. And then when I multiply those together, I get y squared, square root of y squared, which is y times that y.
So you just don't want it there, you want it upstairs. There.
It wants to move up. Yep. All right, make sure your names are on that and anything else you might be handing in. And will you please get out page 109. 109, have that out. Because we're going to kind of go through it together as a class. I want to make sure you feel comfortable with it.
Yeah, we did.
What page?
109. I'm sorry, I didn't understand.
Okay, we'll get you through. Get it done and turn it in, okay?
Oh, can I
Finish it and then turn it in. I'll give you all points.
Thank you so much.
Who's that? No, your son. All right, so I am looking at page 109. And I just want to kind of like, let's take a look at problems 1, 2, or 3. Give me an honest look at 1, 2, or 3. Is there any or all or some that you want to see of 1, 2, or 3? 12. Okay, good. Take a look on page 109. Any of those you'd like to say have you work out? Just shout it out if you want. Yeah. 2. We're in. Page 109. Okay. I have a root 11 and I have a root 3, but I happen to have 2 root 11s. Agreed? And we're just adding these together. So is there a 1 really in front of that? So let's count them up. So I have 9 root 11 plus 2 root 3. Done. That's it. No further. 1 or 3? 'Which one, Brooke? 3? You got it. Okay. Problem number 3, I need to think about my perfect squares. Hey, let me ask you this. Does everyone know how to generate this list? Is anybody stuck on how I'm generating this list? I mean, it's literally 1 times 1, 2 times 2, 3 times 3, 4 times 4. That's all it is.
Are you going to, how far are you going? To 10?
Just on this one to 10, yeah. But
How
I'd say on the maybe on the test we'll have to go up to 12, so you have to go with a calculator 11 times 11. Can you handle it?
Yeah.
Good. All right. Let's take a look at root 28. What appears to be the largest perfect square that could be part of 28? Meaning 28 divided by that number would give me another whole number out. 9? 9 times what? 9 times 3 is 27, okay? So that wouldn't quite work. 4? 4 times 7 is 28. I like that. That's a perfect square. So I get, this becomes root 4 times 7. So let's take care of that. What's the square root of 4? 2. So that's now outside. So then I get 2 square root 7. All right, so far with that? Problem's not done, because now I need to take a look at 63. And what do you think the largest perfect square that goes into 63? Say it. Say what you just said.
9.
9, good. Because 9 times 7 is 63. The square root of 9 is what? 3. So minus sign, minus 3 root 7. Do these appear to be like terms, meaning they have the exact same radicals that we're adding or subtracting? So 2 minus 3 is what?
1.
2 minus 3 is what? Negative 1 root 7. There's my answer. Of course, you could just have it as negative root 7. Either answer's fine. I don't care. Good, Joel?
Yeah. Think
4, 5, or 6? 5? You got it. I'll work more if you need it. Number 5. Let's take a look at number 5. 5. I get root 12 plus 4 root 27 minus 2 root 48. Okay. My first thing I'm going to do is put my perfect squares up. 1, 4, 9, 16, 25, 36, 49. That's about as far as I need to go. Why am I not going any further?
Because the numbers don't go any higher.
Good. Yeah. The number's root 48. I'm already at 49, and I'm not going to get any higher than that. Okay, so let's break this down into parts. So what's the largest perfect square that works with 12? 4 and 3, right? So I'm going to get square root 4 times 3. What's the square root of 4? 2, so I get 2 square root 3. Agree? Plus sign comes down. Let's look at that one. What's my biggest perfect square that works with 27? 9. 9 times 3, right? So I have plus 4 times 9 times 3. What's the square root of 9? 3. What does that 3 do with the 4? Multiply, so I get 12 root 3. Is that okay so far? What about this? What does 48 break down to? What's the largest perfect square? 16. Why not use 4?
not the largest.
Because it's not the largest. Okay? 16 times 3 is 48. So when I be doing this list, I would hope you have a calculator tomorrow. Can you use those? Yeah, but they're way more powerful than you need. Okay? Some of you have a hard time finding the on button on those. Bring that cheapo depot one. Okay? You know what I'm talking about. Okay, so just go, hey, 16 divided by, or 48 divided by 16, boom, 3. Whole number, yay. All right, what's the square root of 16? 4. What does that 4 do with this 2 outside? Multiplies it. Hey, do I have 3 like terms up there? Meaning, do all 3 of my terms have the exact same radical amount? So I can count them up. So 2 plus 12 is 14. 14 subtract 8 is 6. So I get 6 square root 3. Why don't I change the square roots? Because we treat it like a variable. We just count them up or down when we add or subtract them. Yeah.
Can I ask, how do you, the 15?
Number 15?
Mm-hmm.
Ooh. We'll get to it. We'll get to it.
Yeah.
Okay. We're coming. 4 or 6? Okay, move on. 7, 8, or 9? Yeah.
9.
9, you got it. Okay. This is just a big distributive property problem. Does that make sense for me to say that? And remember, when I multiply outside, outside, and inside, inside. Okay? Does that terminology make okay sense? All right, so if I multiply here to here, I'm going to get 2 times 3, which is 6. 7 times 5, which is 35. Seem okay so far? This subtraction sign is going to come along. What happens if I multiply here, here? 2 times 4 is 8. 7 times 7 is 49. Can I break 35 down? Here, let's list those perfect squares again. So I got 1, 4, 9, 16, 25, 36, 49. Ooh, hey, that's going to work there. Can I break 35 down at all? Does like 4 go into 35, or does 9, or 16, or 25, or any of those work? What do you think? No, I agree with you guys. Doesn't work. So 6 root 35 is sticking as it is. I'm not getting any fancier on this one. But look at that. Hey. What's the square root of that? 7. What does that 7 do with the negative 8? Multiplies. Done. That's it. Yeah.
Can we do 7?
7, you got it. Root 6 times root 2 minus root 6. Okay, it's another distributive, another multiplication type of problem. So if I multiply here and here, I'm going to get root 12. If I multiply here and here, I get minus root 36. Does that seem okay so far? Now let's see if we can break our roots down. So I know I got 1, 4, 9, 16, 25, 36. That's about as far as I have to go. Oh, let's take care of the easy one. That's going to give me minus 6. Agree? Square root of 36 is 6. What about 12? What does 12 break down to? 4 times 3. And what's the square root of 4? 2. Done. Why don't I subtract those? Because one has a radical and one doesn't. They're not like terms. What else would you like to see? Go to the next row. Yeah. How much? 11. Yeah. Sophia, you had one as well?
11.
Oh, sweet. Cool. I like when that happens. Yeah, did we just do this one on homework?
Yeah.
We'll do it again. It's not going to hurt us if we see it again. Yeah, this is that goofy one. Okay? So... So that's all the way through 12. So what's the square root of 144? 12. Okay, so that just gives me 12. What's the square root of this? X to the third. Square root of this? 9. Ooh, this has to break up into y squared y. So what's the square root of that? Just y. And then I have that root y sitting downstairs. So I guess I could say, hey, 3 goes here, 3 goes there. I like that. What should I multiply top and bottom by to get rid of the bottom radical?
Y squared.
Not quite
Oh,
y.
not squared.
Root y.
Yeah.
Square root y. Okay, so on top, I'm just going to get this. If I multiply those together, I get y squared. So it's square root of y squared. Y multiplies with that. Done. Again, we had worked that one before. Yeah. 10. That's a good one. Okay. All right. Put my perfect squares up here. That's about as far as I'd have to go. What times what would give me 54? What's the biggest perfect square? 16? Let's see. 16 times 3 is 48. 16 times 4 is too big. What else? 25 won't work. How much?
9 times 6.
Yeah, 9 times 6. Okay, so I got 9 times 6. I'm going to break this up to x squared x, and I can leave that as just y to the 4th. Okay, so what's the square root of this?
3.
Square root of this?
X.
Square root of this?
Y. Y to the second.
Y to the 2nd. Awesome. What do I have left inside?
6 and X.
Done. I'll do number 15. I'll just do number 15 right here. 25 to the 1/2 power is equal to the square root of 25, which is equal to 5. Is there anything else off that front page that you would like to? Yeah, 15? Oh, 15 right there.
Oh.
20. So if you have something to the 1/2 power, it's the same thing as the square root, which then you just get square root of 25. 13? Okay. That's as far as I need to go. What can you tell me about this one? They're both perfect squares. Very good. What's the square root of 49? 7. What's the square root of 36? Done. Notice I keep writing the perfect squares up there because I'm using it as a tool. And this one was nice because it's like, dude, my 2 answers just showed up. That's kind of cool. Anything else off that very front page?
Just to double check. 14?
14?
Yeah.
What is that? Root 3/4? Hey, what's the square root of 4?
2.
So I get square root. Done.
Yeah, that's it.
Yeah.
You do nothing with the square.
Okay. Done. Turn the page. Ooh.
Wait, is it the amount of time that
We don't need to worry about either of those. We don't need to worry about either of those. Go to page 111. Take a look at page 111, please. Is there anything on page 111 you'd like to see 1 through 12? Yeah. 12. Yeah, buddy. So I'm on page 111. And we're going to look at number 12. I get 2 root 3 and 4 root 6 minus root 8. Does this seem okay so far? This is a big distribute problem. So I'm going to multiply here, here. So that's going to give me 8 root 18. So outside, outside, inside, inside. If I multiply here, that's minus, and I get 2 root 24. Does that seem okay so far? Yay? Not done yet, but we're still working. So 1, 4, 9, 16, 25. That's as far as I need to go. What's going to break 18 down nicely? 9 and 2. Good. So I get 9 times 2. What's the square root of 9? 3. 3 times that 8 becomes 24. Minus. What about this one? What does 24 break down to? 6 and 4. Good. What's the square root of 4? 2. What does that 2 do with this 2? Multiplies. Can I go any further with this problem? Do I have the same radicals? No. That problem's done. What else do you see on that? 4? Can I move off? 4. 3 root 12x parentheses 2 root 6x parentheses. So outside, outside, inside, inside with multiplication, right? 3 and 2 is 6. If I multiply those together, I'm going to get root 72x squared. Do you feel comfortable with that so far? Let's put my perfect squares up. Okay. Which one seems to work with the 72? 36? Yes. Good. 36 works. So I get this. So what's the square root of 36? 6. What does that 6 do with the 6 outside? Multiply. Is this a perfect square as well? What's the square root of x squared? What do I have left behind? Done. What else off that page? Yeah. 10? Yeah. So everything's being multiplied together, so I multiply inside, so I get 2 root 36. Do I need to write my perfect squares, or do you feel comfortable saying that, hey, square root of 36 is 6? 6 times the 2 is 12. Done.
9. Oh, you just multiplied.
9? 9 to the 1/2. This is like the other one. It's just square root of 9, which is 3. Anything else off that, page 111? Yeah. 2? Yeah, well. Number 2. Squeeze it right here. 80, a to the 5th, b. All right. Let's put my perfect squares up here. Got 1, 4, 9, 16, 25, 36, 49, 64, 81. That seems good enough. All right. What times what gives me 80? I know 10 times 8, but I want a perfect square. 5 times something.
16.
5 times 16, absolutely. Okay, so 5 times 16 is 80. And then I'm going to change a to the 5th to a to the 4th and a, and then b. Okay? Let's break it down. Square root of 16. 4. Square root of a to the 4th. A squared. What's left behind? 5. A, b. What else off that page 111? or 112? 8? Can anyone just look at that and tell me what the two perfect squares that are going to work? Yeah, 25 times 2 and 25 times 3. Feel okay with that? Square root of 25 is?
5.
What does it do with that 2? Multiply, so I get 10 root 3. Square root of 25?
5.
Times the 1 out front.
5.
Oh, that's a 2! That's a 2! Holy crow, that's a 2 right there. That's a 2 right there. I'm so sorry. Cool, there's your answer. Anything else? Up through 112, I guess? Okay, so I will tell you this, and this is your choice. Absolutely 100% your choice. So page 109, page 109 through 112 is a good review. Oh my gosh, I can't spell. Review for quiz tomorrow. Okay? So when I say it's a good review, I don't mean I hit you out, go have to do it. Okay? Might have a couple minutes in the beginning to do it. Find yourself an easy calculator. You know the junk drawer at home. You know where I'm talking about. You know that calculator's been there since you've been 7. You know it's been there. Grab that one. No one's going to miss it. It's going to help you out. If you don't bring it, then yes, you could use these. So that's all I got for you. So don't leave until a minute before, but that's all I got.